Okay.
Sorry, guys.
Yeah, sorry about that. No idea if this is actually doing what it's supposed to do, but.
As he's going through the slides, you might want to follow along with the code. It's at github.com/DVTO, and you'll see the first one, DVTO 6. So it might help if you follow along.
Yeah. All right. So, yeah, how many of you have used D3 before? All right. Cool. All right. That's good because this is aimed at the beginner level, basically. So, what is D3? D3 stands for Data-Driven Documents, which you maybe already know. It's incredibly powerful, and I mean, it uses SVG. That's the big thing that's going on here. But I assume most of you have seen the examples that are on D3.js.org. And if you're not impressed by those, then you must be from the future or something. I don't have much to tell you. Basically, I love it because it's the kind of library that really showcases what JavaScript's capable of, and it really kind of helps redeem JavaScript a little bit. Because, well, I'm sure you know JavaScript can be a bit special sometimes. So the Toronto parking ticket dataset, they have a bunch of years available. Goes back 5 years or something, and it has stuff on the date, the time, the type of infraction, how much the fine was, the province that the license plate was for, stuff like that. And we're going to be using the 2012 data. 2013 data is out, but it didn't play that well with Python, so I used 2012 instead. So the thing with D3 is that when you're trying to get started, it can be a bit daunting because it's the, well, let me see if I can show you here. The documentation page alone, like if I go to API reference here, it goes on for a really long time. There are a lot of methods, and each one does a very specific task. That's the beauty of it, really, because you can chain these together in all kinds of ways, and that's how it's so flexible. But that doesn't mean you have to build up your visualizations piece by piece. There is no single function that you can pass stuff into. If you've ever worked with, like, if you've worked with R, I don't know, has anyone worked with R? Okay, well, in R, it's more like the base plot system versus like the lattice system or something. It's like you have to build things up bit by bit. Oops, let me push back down here. This. But don't panic. We're going to take it slowly. Okay, we're just going to start with a nice basic pie chart. So if we look at the DOM for this guy. You know, after all this stuff, the meat of it is we have an SVG that has a width and a height. We have this G element that's been translated. If you look at these numbers, you'll notice they're exactly half of these numbers. So this G element has been translated to be right in the center of the SVG. And then we have 4 path elements, each of which has a D attribute and a fill attribute. You notice the fill is just a color. And that's what produces this. There's no CSS here at all. This is all just SVG. So how do we do that? So we're going to start with just some dummy data to begin with before we get into the Toronto data. So I just have a little array here, 10, 20, 30, 40. That's what, if you look at these sizes, that's kind of what that is. Oops. We'll just define some dimensions here. Width, height, and the radius is going to be the smaller of the two divided by 2. So now we start getting into the actual D3, though. So we're going to start by defining our color palette. And D3 has a number of built-in palettes. Well, the data set we're going to be using only has 10 elements, so I'm using the scale category 10. They have a scale category 20, 20B, 20C, but you can also just define your own set of hex values or whatever. And it will just iterate through them, and if it runs out, it starts at the beginning again. So, but that's not going to be a problem for us. So now things start getting a little more interesting. So pie charts are circular, obviously, and so how many of you have worked with polar coordinates before? Well, yeah, if you've heard of them, basically with polar coordinates you have an r and a theta. The r is the radius, the theta is the angle, and that the arc here is basically the r in polar coordinates. We're defining that we're going to have D3 arc, and that the radius, the outer radius, is going to be the radius minus 10, just have a bit of room on the top and bottom. So we're going to work with this a little more later, but for now this is all we need. And, well, it's pie chart, so we're going to use the pie layout. This part should be straightforward. This part is the interesting part. What the value method does is it takes an accessor function. And basically this is you're telling the pie chart how to get the numbers out of your data set. Because it has to calculate the angles. That's what the pie function is going to do, is calculate all the angles for all the wedges. And in our case, if we look back at our data set, oops, too far, all we have is an array of numbers. So there's nothing to do. We can just return the number itself. It's just an identity function in this case. This is going to change a little later, but for now, that's it. All right, so SVG time. Now, this looks like a lot of stuff, but it's really not too bad if you go at it piece by piece. We're going to select the body. If you've ever worked with jQuery, this should seem pretty straightforward. We're going to select the body. We're going to append an SVG tag to that. We're going to set the width and height attributes to be the width and height that we defined earlier. Then we're going to append a G element to that SVG, and we're going to transform it so that it is exactly in the center. And if we look back at our DOM from earlier, this should help make it a little more clear. So we found the body, we added the SVG tag, set the width and height, added a G, and translated it. Okay? So now all we have to do is add these path parts. So no problem so far, right? It's easy mode still. And so here we get to the fun bit, the select all data enter append pattern, which you will see again and again if you're doing D3. If you're looking in the examples, you'll see this all the time. Select something, dot data, dot enter, dot append path, dot adder, dot adder. And I know what you're thinking. This looks like, it's like, what the hell is this? But if we go at it piece by piece, it isn't too bad. And you will get used to it because you're going to see it again later. So basically, we're going to select all, like, we start with a selector, so we're selecting all the paths, which don't actually exist yet, but then we're going to bind the data, our pi value, so all our angles, to the selection. The enter method just creates basically a placeholder node for all the points, all the data points that we have. In this case, we have 4 data points. So then for each of those 4 data points, we're going to create a path, which if we look here, so we have four data points, 4 paths. And then the D attribute, which you'll remember from the DOM, hopefully. Don't worry about what it means, but we pass in the arc that we defined earlier, the arc function. And then finally, we're going to add the fill attribute, which, if you'll remember, is just a color. And what we're doing here, this is basically an iterator. It passes in the data point and an index. And for now, we're just going to take the index. We don't really care. We don't have to. we'll come back to this later, but for now, this is good enough. So I know this looks like a lot, but and this is the kind of the point where people maybe start to glaze over. But don't worry about it. It's fine. Because as I mentioned earlier, the flexibility for D3 comes from how it keeps all these. Everything is very small. It's very composable, well, chainable, and this is just happens to be a pattern that you have to use quite often in a lot of charts that or visualizations that you might want to make. So we look at what's going to happen if I click on this one. I'm just going to copy that for now. We look at what that looks like. It just looks like this. And we look at the code.
You increase the font size?
Sure. Or not. Maybe not. It doesn't want to let me. Oh wait, I'm using the wrong. Sorry, using the wrong key. So we find our data with type, radius, color, arc, pi, the SVG, and then the path. And this is when stuff happens, and we get our nice, nice colorful pie chart.
I'm curious. For something like a pie chart, when wouldn't you use an arc?
You always use it.
Okay.
So
It just seems a little.
yes, yeah. Well, yeah, that's the point. Is that well, actually, that's good. Actually, that's actually a good time to mention this. NVD3 is a library that basically wraps up a bunch of D3 functionality into ready-made things. So it's a lot easier to get started with. Sorry, I meant to mention this earlier, actually. You still see some of the similar sort of D3.select data, but there's a lot less code overall because you're going to be defining a NV. Let me zoom in here. Where you can define. They have all these models. In this case, we're doing an NV model pie chart, and so they have a lot of functionality here that makes your life easier. And so this is a great way to get started with D3, is to look at NVD3. The issue is simply that you lose some of the functionality and some of the flexibility. D3 is intentionally low level because it gives you a lot more power. But I really suggest you take note of NVD3 and keep that in mind if you're looking, because they've got all kinds of examples here ready-made for you to try out. But you guys you're ready for something a little more stiff, a little more fun than that. So that's why we're going to the vanilla D3. We have a very basic pie chart at this point, but we haven't started talking about parking at all, and that was kind of the whole point. So let's move on to phase 2. And in phase 2, we're going to do two things. We're going to start using actual data from our Toronto data set, and we're going to switch to a donut chart, just because we can. And it's going to end up looking like this. The donut part is the easy part, really, because this is going to be the easiest thing in the entire presentation. All you have to do is add one line. This was what we had before with our arc. We were just defining the outer radius. Now we're just going to define an inner radius as well. And note the difference between these numbers is 100, so we end up with a pie chart that's 100 pixels wide. And that's all we have to do to make a donut chart. So that's pretty easy. Now let's look at some actual data. So for this, I can't show you that. We took the data set, which is, I don't know, 2.8 million rows and 10 columns or something, 11 columns, and did a bunch of aggregation on it. And in the Git repository, where was that? Git DVTO 6. There is an IPython notebook that contains all everything that was done on the data to produce the CSV files that we have in this. So we have provinces, times, weekdays, fines, infractions. We're going to look at some of these later, but for now we're going to be focusing on the province. And as Dan mentioned, there's tickets given to people from all over, including Hawaii. I don't know how that works, but there were 11 tickets handed out to people with Hawaiian license plates in 2012, which is rather small compared to the 2.6 million Ontario tickets that were handed out. So this just took the top 9 provinces and states, and then collected everything else into an other category, which is why other is the second largest one here, because it covered all the other states and provinces. What are we going to do with this? The nice thing, so as you notice, this is a CSV file. We've got our header here, and then 10 rows. And D3 provides methods for reading CSVs as well as TSVs and arbitrary DSVs, delimited by whatever you happen to have. When you use the CSV function, it will parse out your CSV into an array of objects where each object has the key values that correspond to the column headings and the column values. So basically, so we get 10 of these with province, Ontario, count, whatever, province, other, count, whatever, which is quite nice. It makes it more sensible for accessing the data. You can use, key names instead of indices. Now the thing is that this is an asynchronous call, so to get at the data, we have to provide a callback, which is what we've done here. So we just say d3.csv, the name of the CSV file, and then unless something goes wrong, it's going to give you back some data, which is this array of objects. Now, we have to wrap our path, which was the very last thing, in this, because we're going to be passing in the data into that, and we need obviously to have the data before we pass it in. So this at this point is unchanged. All I did was add this d3.csv and this stuff, and then I just copied this guy into here from outside of the callback. Nothing else has changed in here. The only difference being that previously this data here was an array of 4 numbers, and now it's an array of 10 objects. Now, CSV fields are strings, so that's why this little guy is there. You'll notice him right at the start here. Right after I get the data, I'm going to go through the data, and I'm going to do this. Does anyone know what that does to my count? Yeah, exactly. It casts it to a number because Python, because JavaScript. You could use parse int or parse float here, but this is faster for whatever reason. So that's what we're going to do. And you will see this in a number of, well, quite often when you're looking at D3 examples, this or some variation on this. There is another way you can do it by defining a function outside and passing it in as another parameter to the CSV thing, but that. basically, if you want numbers, you got to do something like this to get numbers. So we now have our array of objects now has the second field being numeric. All right, so that does mean we have to make a couple of changes elsewhere, though. So previously, remember, we just had this identity function in the pie chart where we were just taking D and returning it right away. But now, well, that was fine when D was a number, but pi needs a number, so that's why we have to change this guy. So now we're going to, D is an object, it's one of these, so we have to call return d.count, so we get the number out, so that pi is able to calculate all the angles, and we don't have to do any of that ourselves, because that would suck. All right, so just like that, easy peasy. Now we have, copy this here. Now we have this, and if we look at code here, it's very similar. The only differences are we have to put this .count on the in the value accessor, and then we've just wrapped our path here inside this D3 CSV callback. Okay.
So this is basically a question.
Yeah.
But what the hell is that data?
Oh, this one?
Because I'm trying to look at the bottom, like, okay, so you have SVG selected, data, bottom.
Right here. That's it. Yeah.
Sure. But
So-
where's the scope? This one inside.
Well, the pi.
Where is that the scope of this?
Yeah. Sorry, I should have used deeper indents, perhaps. This guy passes in data, and then after we do our little number dance here, then we just pass it directly into this pi function, which then goes into data, and that's where all the angles are coming from.
So you took the previous example, you qualified the data, but you didn't standard CSV.
Yes. Yeah. I scrapped, earlier I had that var data equals 10, 20, 30, 40. Scrap that, and now I'm getting my data from the CSV. And that's the only change there. So that means we can move on to case 3. And yeah, so we've got this pretty chart, but what does it mean? I mean, we look at it again here. Whoa, it's big. I don't know. It's just colors. It doesn't mean anything. So we need a legend, and not this kind of legend. We need this kind of legend. So how do we do that? Now we finally have to start getting some CSS into here, but not much. And really, it's just to make these guys less ugly and more, platform agnostic. So we're just going to set the font to be 10 pixels sans serif everywhere. And yeah, I think it's important to take note of the fact that we haven't used any CSS yet. We have this pie chart, all kinds of colors and shapes and stuff. No CSS anywhere yet, and barely any now. So this is, earlier I mentioned that on this path thing, the thing that does all the magic, at the end when we were filling the colors in, we have this the data point and an index getting passed in, and we were just taking the index, which was fine. But now we want to be able to link the province name with the color. That's going to be important. That's how we're going to be able to produce this pairing. So instead of using the I, we're just going to pass in the d.data province. Now, D is the data point, and at this stage in the cycle, the province and count values have been moved into this data subobject. And really, all this is doing is it works. The colors are going to look exactly the same as they did before. The only difference is that now they the color and the province names are attached. And so we can start working on our legend. And we just need, there's three things really: a wrapper, just to kind of position it, the colored boxes, and then the text. So this legend, again, this looks like a lot of code, but it's really very straightforward when you look at what it's doing. It's, again, we see our good old friend select all data and pin. Same thing as before. Select all legend. The data in this case is the color domain, which means all of the color values that we're using. Enter, because we need to get the placeholders. We append to G, and then we can put our attributes on there. In this case, we're just adding a class legend, and we're going to translate it. Now, this is a little cryptic, I admit. Basically, it's already centered, so we don't have to do anything in the x-coordinate. But in the y-coordinate, we want to, or in the y direction, we need to kind of space them out a bit. And that's all this is doing. Putting, 20, because I is an index here, so it's going to be 0 times 20, 1 times 20, whatever. And the minus 100 just moves it up a little bit. Don't worry too much about that. But, so that's our wrapper. All that does is just create a space for the rest of it to go. For the colored boxes, it's really easy. We just take our legend that we defined here, and we add some rectangles, one for each data point. We give them a width and height. We move them a little bit backwards so that everything is nice and centered. So move them back minus 18 pixels. And then we just fill them with whatever color we're told to give them at this point. Okay. And the text is even easier. We have our legend that we already defined. We just append a text node to it. Give it, this again is just the only reason we need this is so that it lines up nicely. So people like Ryan don't yell at me, or Dan. Yeah. And the text, in this case, again, this is just an identity function, but what it's doing is returning the province name, because that's how we tied the colors to a province name. And so that was very easy. There wasn't much to do there. Adding the legend is really quite straightforward. If we take a look at it here, zoom in a little bit. Everything's the same. I think it's the same right there. Basically, it all happens inside the callback, inside the D3 CSV callback. Here's our path that we defined earlier. That's the wedges. And the only change here was that instead of using our index, we're using the province as the keys. And then here's the entirety of what's needed to do the legend. This is creating the wrapper. And then we add the colors here, and then the text at the bottom. And we end up with everything nicely lined up. So you'll see these guys are 18 by 18, and this is the center line here. So that's why they've been moved back minus 18 pixels, so that they are just on the left side of the center line. And the text, the 4 and the 13, are just to make sure that these guys line up as nicely as possible. The 4 pixels is between the box and the text. Okay.
So,
Mm-hmm.
Sorry, yeah.
No.
Why are you saying here? You're turning legend object, so you are selecting very geometric, like all the SVG elements with the legend class.
Yes.
And it doesn't find any of the creation.
It creates them based on the data, yeah.
Yeah, so then it says, well, if it exists there, it updates them.
Well, this thing is only going to get run once, so, but that's kind of getting to how you would do that.
I'm just guessing based on that.
Yeah.
So everything that's a legend in here, I guess it creates them based on color domain?
Yes, the color domain. So the color domain in this case is going to be the 10 colors that we're using. A list or an array of the 10 colors that we're using.
Just because we have 10 categories of data,
Exactly. And the enter just creates the placeholders, 10 placeholders, to which we append the G element. For, like, for each of those 10, we create a G element. If you look, actually,
And G is like SCG.
yeah, oops, sorry. If we, let me just zoom out. If we inspect element here, too big, sorry. Here, we have our legends. So we just, for each one we have the G element, the class legend, the translation. And notice how it goes 100, 80, 60, 40, 20, because we had that I times 20 in there. And within each one of these, we have a rectangle with the width, height, style, x-axis, or the x offset, and the text.
SCG understands how the form label is the actual.
Yes.
Yes. And G stands for group. That's just a group. So you can move them together.
So here we have, we've got the class legend, add the transform attribute, very, very jQuery-like. Add the rectangle with the various attributes, add the text with the various attributes, and then you're done.
So how does that mesh with we have an X attribute?
That's like a, yeah.
So you're saying the decrease down center?
No, the base element that we're working off of was translated right at the beginning. The path, that's why it's centered, is because of this. Not this, sorry. This right here. When we create the SVG originally, we append the first G element and we move it right to the center. So that kind of creates our frame of reference. Yeah. The X attributes are absolute, whereas if we used a DX or a DY, that would be a relative shift. Relative to the frame of reference in which we find results, basically. Similar to just working with CSS more generally. So we have a legend and we have a donut chart. Now, phase 4. So we have this chart, and we can see the relative sizes of things. But what if I want to know the actual number of Ontario tickets that were issued? So we're going to add some tooltips. When we hover over a segment, we want a little tooltip to appear with the province name and the count. And so first things first, we've got to add a bit of CSS here. Nothing too fancy here, just basically making sure it's on top. Doesn't look too ugly. And once we have our tooltip class, then we're going to create 3 event listeners. We're adding these to the path, which if we look back here, is this guy here, the one inside the D3 callback that actually adds the wedges to the SVG. We're just going to take this path variable and attach 3 listeners: a mouse over, mouse move, and mouse out. And we're going to create a tooltip on, tooltip move, and tooltip off function to handle, or event handler for this. But before we do that, we're going to have the tooltip is just going to be a single div that we're just going to move around as we need. We're not going to create pile or like a tooltip for each data point or anything like that. We're just going to have a single tooltip, and we're just going to add it to the body. So in a very jQuery-like fashion, we're going to select the body, append a div, and give it the class tooltip. No problem there. So the mouse over handler is going to happen when the mouse, first comes into one of our wedges, one of our colored segments. And there's not much we need to do. Basically, we're going to, this content variable, we're just saying we want a div with the province, and then a div with the count, and then just stick that inside the tooltip. Replace whatever's inside the tooltip with current province and the current count. And we need to make it visible, because I'm not sure if you noticed in the CSS, but it was set to be invisible. So that's kind of important. So that's pretty straightforward. Now, this is probably the trickiest of the three. And it's really not that tricky. Basically, what we want to have happen is when we move our mouse around while we're still on one of the sections, we want the tooltip to kind of move with us. That's just there's lots of ways you can move tooltips with this particular graph. That's what I decided to do. And luckily, D3 gives us this D3.event that tells us where the mouse is right now, the Y and the X coordinates. So I'm just going to set the style of the tooltip to move there with just a little bit of a buffer. The +10 is just so it's not right underneath the thing, right underneath it. It's a little bit to the side. For the mouse out, this one's the easiest of all three. We just make it hidden again. When we leave the graph, we want the tooltip to disappear. So we're good to go. So let's try it out here. Copy the image address. And it looks like this. Looks very similar to before, but now when I hover over it, I get this little guy. So a nice little shadow. And as I hover over these guys, I can see things changing. I can move them all over the place and he stays with it. Very fancy. Very fancy. And if we peek at the source, oh, okay, here's my fancy CSS. Not much to see there. And then this is where I attached my handlers for listeners. Right after the path, I just say path dot blah blah blah. I could add them to this declaration too. Like I could have, instead of having a semicolon here, I could have just had nothing and then just added them to that. But I just thought this was a little cleaner. And up here is where the tooltip stuff I don't need to define inside the callback because everything it needs is either already there or passed into it when it's being called. So these guys can be defined outside of callback. The reason being the only one that really would matter is the tooltip on. When you first hover on it, you need to be able to get the province and the count out, but the data point that we're hovering over is passed in, so we don't have to figure that out. It tells us. Yeah. So that is all we need for that. Now, really, we've done quite a lot. If you look at that, if you look back here, and there's quite a lot going on here. But there's one more thing that would be kind of nice, and that's to add a bit of interactivity, get things moving on the screen a little bit.
Pause for the GIF.
And to have a sip of beer. It's a good GIF. You got to give it a chance to. Right. Now, one of the things that makes D3 amazing is its ability to enable interactivity. And as you've noticed, this chart, because it's Toronto data, most of these tickets are from Ontario. Makes it very hard to get a sense of these other ones. So, wouldn't it be nice if we could add a little toggle here that let us exclude Ontario, so that we could go from this to this and back and forth. So how are we going to do that? First, we're going to add this ugly little form to the page with some wonderful CSS here. And I mean, we could use the legend to do this, But one thing that's a little more complicated, and also I thought it would be good to show how, like, this form isn't involved at all in the SVG. It's completely external to the entire thing, and yet we're able to use what's happening there to affect our visualization. And that's one of the neat things you see with D3 with some of the more advanced visualizations is that you change something in one section and then everything else updates accordingly. And so this kind of gives you a little bit of a sense of that, where this thing is outside of this, outside of the SVG, and yet it's going to control what we see. So our form is very, very basic. It's just 2 radio buttons. And what we're going to do is use D3 select all, find all the inputs. Now in this case, the page only has 2 inputs because it's a very simple page. We don't have to be more specific, but I mean, we could use more advanced query selectors in here if we needed. We could have added
CSS selectors?
Yeah. Because I think probably under the hood it's using the native JavaScript query selectors that these days are that handle the jQuery style collections, unless you're using IE. So we're just going to register an event listener. If you change any input on the screen or on the page, we're going to call this change function. So what does change do? Well, change has a this. In this case, this is the input that was just changed. So we can look at the value of this. And we really only care about one thing. Is it set to yes or is it set to no? If it's set to yes, then we don't have to do anything. This is exactly the same pi value function that we used before. We're just returning the count for all things because we want to include Ontario. We don't want to change anything. It's a regular chart. But if you said no, then we're going to basically filter out Ontario just by setting it to 0, down from the 2.6 million or whatever. We're just going to say, no, we're going to call that 0 for now. All of the provinces are just left alone. So then we have to update our angles. Because obviously the angles are changed if the biggest guy is gone. But we don't want to just do it in a jerky fashion. We want to animate it, and that's where this guy comes in. So we're going to do a transitional change, duration 750 milliseconds, and this guy. We're going to, again, this is D function. If you remember earlier, that is related to the I for a pie chart. And we're going to, and adder tween is, I think I mentioned this in the next slide. Maybe. Oh, sorry. Adder tween is lets you transition smoothly between dates. So we'll get to this in a minute. Before we deal with the animation, though, there's a little bit of housekeeping that we have to do in other parts of the JavaScript. First thing we're going to do is add this sort null to our pi, where we're defining the pi variable. We could have had this in there from the start, but it just complicated things a little bit. I didn't see a point in keeping it in there. We don't have to do this. I could show you what you can. Well, you can try it out yourself. If you take it out, it's just the animation looks a little weird because you have things closing and opening in opposite directions, and it looks a little whack. So we're going to turn the sorting off so that it's a little more kind of linear in the way that it changes. Also, this was what we had before for the path. our old select all data and append thing. The biggest change here is that whereas before we were calling this .data method, we were passing in the pi function given the data that we have. I probably should have called this something other than data because it's a little confusing. But anyways, the thing is, we now want to kind of keep the base data set the same. We just want to change the values the chart is using. So we're going to define this. We're going to use the .data method instead to pass in the data. This means that it won't be like joined to the elements. It's left kind of pristine, and we still use our data pi function, and that's how we're able to update things back here, is because we, note this is the same path.data pi, same declaration as here, path.data pi. So I'll talk about this more in a second. The only other change here is this guy. We need to keep track of the current D value so that we can do the transition smoothly. Don't worry too much about that right now. But you'll see this underscore again in a second. Okay, so as I just said, moving data into .data keeps it from being joined with the selection, which is what happens when we use .data. Whatever you pass into .data gets joined to the selection. The selection being select all paths. The last line, as I said, attaches this current value to the data point because we're going to need that to keep track of our animation. So the arctween sounds kind of evil, but in this I literally yanked this verbatim out of some other D3 animation. I didn't even change it because it worked as I needed it to. And when you start playing with D3, you're going to be doing that sometimes. You're going to see something like an arctween and be like, what is this? But I know I need it, so I'm going to use it. Basically what this is doing, you'll see this D3.interpolate, it's taking the past value, the underscore correct, the one that was before, and the current A value, the current value that we have, and just interpolating between that. And this is just going to let us have a nice smooth transition between states, which we'll see. Basically, like, transitions are pretty advanced, so don't worry too much about the details of this. It's just kind of take it at face value. Because at this point our chart is done, and we can see what it looks like here. Oopsies. There we go. All right. So very similar to before, we have our legend, we have our tooltips, but now when I click no, look at that. Wow. I mean, I could do this all day. Yeah. I can't click it fast enough, but yeah. So now I get a feel for the fact that other is pretty big. That all the other states and provinces aren't listed here. That takes up quite a big chunk. But we see how big Quebec is. We see that New York and Alberta are pretty similar. Florida, a lot of Florida people. Yeah, that's surprising. Yeah, Nova Scotia, Florida, Michigan, Manitoba represent. So
more Florida than Michigan.
Yeah. Yep.
More Alberta than New York. How does that make sense?
Yeah. Yeah. Well,
more Alberta than Manitoba. Or Saskatchewan. Saskatchewan's not even in here. So, yeah. Let's do this a couple more times because it's fun. And, yeah, if we look at what we've got now. Oh, this is the wrong one. All right. So this is the extent of our CSS at this point. And there's really not much to it. Basically, we just tried to make the fonts a little more standardized. This is just to make this little form show up here as opposed to over here, and so that it has nice, cursor pointers. This was the biggest piece of CSS, was just defining the tooltip, and I mean, we could have done without that mostly if we just made sure the text was black, you could have seen it just clearly. Then inside our body, we just have this little form that lets us toggle between the two. And then, I mean, when you look at it here, it looks like a lot of JavaScript. And that's kind of the problem with D3, is that you see an example like this, and you're like, oh, that's not too hard. And then you come in here, and you're like, holy crap, I have to do all of this to get just this little thing. And yeah, you do. But the point is that you can also do, you know, amazing stuff with D3. When you look at, you know, this kind of thing. Well, the famous show reel. This gives you just a sense of the kinds of stuff you can do with it. I mean, it's a very, very dynamic, very powerful and expressive platform. Yeah. Yeah, no kidding. Yeah. Yeah. Hey, look at that. Yeah. Yeah. Like I said, if that doesn't impress you, there's something wrong with you. So.
That's only 3 million lines of code. So.
Probably not that bad. But yeah, look, you have a nice 3D bar chart.
You can probably click it.
Yeah, I know.
What, like a 3D view dragon?
No, it's not that bad. Well, it's only this much code. I mean, really, what a grace. But the thing that I wanted to drive home was that there's a lot of stuff here, but each thing is very small. Each thing does one task, and it does it well, and it only does that task. So you don't have a lot of conflict. You don't have to worry about things. You know, if you pass in the wrong parameter, well, if you pass in the wrong parameter, it's not going to work. But the docs are very clear. You can tell very easily what things do. Go back here to the documentation. Yes, there is a lot of it, but that's a good thing. If we look at our selection.enter, this was part of our select all data enter append thing. So yeah, it returns placeholder nodes for each data element for which no corresponding existing DOM element was found in the current selection. And yeah, so basically, when we select all these divs and we pass in these data points, if they don't exist, enter is going to make them false, so that we can then stick the div on them and give us the data that we need. So the the existing, yeah, it'll take whichever ones are placeholder nodes that for which no corresponding DOM element exists. So yeah, it'll find the ones that are there. You've already selected them. That's why you do this select business up front. Is that we're saying here we're selecting all the paths, and if they're there, great. After I pass in the data, the pi data, if the ones I want are there, great. Otherwise, I need to create them. It also does some cleanup too if there's ones that aren't needed anymore. You can get rid of those. So there's an exit function that yeah, you can get rid of the ones that are already there. And the datum, this was, if you remember, when we wanted to do the animation, we had to switch to datum instead of data. And that's because this method does not compute a join, and thus does not compute enter and exit selections. And that's what keeps the data clean. Whereas the data, which we need, but we can control what we pass into it, it does do a join. So it joins the specified array of data with the current selection. That's why when you want to move stuff around, you have to use data. So that was a lot, I know. Thank you for sticking with me through all that. And yeah.
So let's grab,
Yeah, let's get some
before
food.
it gets too cold, and then come back for.
Yeah, because I created some other data sets here for us. Because this one, you know, it was called D3 with Toronto Open Data, whatever, but we only used one, just the provinces. Let me get DVTO. Oh, yeah, sorry, the bottom right.